Okay students, good morning, welcome. Now today we'll start the new topic, right? That is the Rolle's theorem and mean value theorem. This is the end of the chapter. That is the last topic of our chapter. Now here we have completed the miscellaneous exercise also. So now we move on to the new topic, which is very easy. Now here it is a Rolle's theorem. So f from closed interval AB to R, this is the domain and this is the codomain of this function, be continuous in the closed interval AB, it is continuous at the closed interval AB and differentiable on open interval AB. The function which is given should be continuous on this closed interval AB and open interval on में वो differentiable होना चाहिए. That is the condition, necessary condition for applying the Rolle's theorem. Such that f of A is equal to f of B, where A and B are some real numbers, then there exists some C in this open interval AB such that f dash C is equal to 0. So this is the Rolle's theorem. You know that this all polynomial functions and trigonometric functions are continuous in closed interval and differentiable on open interval, and therefore here is whatever is the given is most probably it is polynomial function or the trigonometric function. Now we'll write whenever the verify Rolle's theorem आपको करना है, that is our example 42. So verify Rolle's theorem for this where A and B is given. So first of all this continuous and differentiable ये condition satisfied होनी चाहिए. That means we will write y is equal to x square plus 2 is our function is continuous at close interval minus 2 to 2. We know that polynomial function is continuous and differentiable at open interval minus 2 to 2. This is the first line in every sum that is compulsory to write for you. So that it is continuous at close interval and differentiable at open interval is true for all polynomial function that we know. Then at this and therefore f dash c belongs to in this interval. मतलब कि आपको c की वैल्यू फाइंड करनी है between this minus 2 to 2 such that f dash c is equal to 0. So we will take here f dash x. Our fx is, we'll write here instead of y you can write fx. So here f dash x is what? 2x. Then if you take f dash c, that is 2c, and if you want this equal to 0, so f dash c equal to 0 implies 2c equal to 0 implies c is equal to 0 वैल्यू मिल गई आपको. So if this is equal to 0 यहाँ इसके बीच में आता है या नहीं that you check. So if 0 belongs to this, so we can write that this is what the value of c in AB. For that f dash c is equal to 0. So you have to find the value of c. So you will write that therefore 0 c is equal to 0 belongs to minus 2 2 such that f dash c is equal to 0. This is our final answer. So in the Rolle's theorem you have to find the value of c belongs to this open interval AB for which f dash c 0 होना चाहिए. That is the main concept of Rolle's theorem. Do it. Then we'll go ahead with more example to verify the Rolle's theorem. So here is example 42. Then write down verify Rolle's theorem for, here is the function and the values are changed, and that verify Rolle's theorem for x square plus 2x minus 8, x belongs to the closed interval minus 4 and 2. Okay, so now what? You have to find the Rolle's theorem. This is exercise का question number 1 है. We'll do all the sums of Rolle's theorem first. then we go ahead with the next theorem, right? So we'll practice for this. Now here verify Rolle's theorem for this function now. So this is again the polynomial function, and we can write that fx is equal to x square plus 2x minus 8 is continuous at minus 4 to 2 and differentiable in open interval minus 4 to. A line always compulsorily you have to write first, right? Then we'll find f dash x. We will find f dash x. So f dash x is equal to what? Here 2x plus 2. The derivative of x square plus 2x and 8 की derivative 0. Now what you will find? C belongs to open interval minus 4 to such that f dash c equal to 0. So now you will take f dash c. So that is 2c plus 2 and you will take that f dash c equal to 0 implies 2c plus 2 equal to 0. Then what is the value of c here? So here it is 2 common. So c plus 1, that is c is equal to minus 1. Now minus 1 is in this interval or not? Minus 4 से 2 के बीच में minus 1 is there? Yes. So we'll write that minus 1 belongs to minus 4 2. That is the value of c. Such that here it is f dash c is equal to 0. You understand that? How to verify the Rolle's theorem? So you do that. Then we'll go ahead with some more sums. Okay. Now this question 2. Examine Rolle's theorem is applicable to any of the following function. Can you say something about the converse of Rolle's theorem for this application, for this example? Converse of Rolle's theorem matlab ki if f dash c is equal to 0, then there exists c belongs to this open interval. F dash c is equal to 0. Then it is continuous and differentiable function. So, but converse के बारे में हमारे कोर्स में कुछ नहीं है. So we'll take that converse is not applicable. अभी हमें वो चेक नहीं करना है, right? Now here fx is equal to box of x for x belongs to 5 to 9. What is the necessary and sufficient condition for the Rolle's theorem? That Rolle's theorem says that here this given function is continuous in closed interval and differentiable in open interval. But we know that it is the greatest integer function and greatest integer function is not continuous at every integer. Integer पे वो उसकी value change हो जाती है, right? So we'll write that first and second both. It is greatest integer function is not continuous at every integer. Therefore, condition for Rolle's theorem is not satisfied. Rolle's theorem की condition ही यहाँ पे satisfied नहीं है क्योंकि it is not continuous. We know that the graph of that is like this, right? And we know that at every integer it breaks. At every integer the value change, and therefore here it is what? It is not continuous, so not differentiable. That means Rolle's theorem is not satisfied, and therefore Rolle's theorem is not applicable, right? And third, 1 and 2 का लिख दिया, then third, fx equal to x square minus 1. Now this x square minus 1 is a polynomial function, and polynomial function is continuous, right, in R and differentiable also. So we will write that fx is equal to x square minus 1 is continuous at close interval 1 2 and differentiable in open interval 1 2, right? We know that is the polynomial function is continuous and differentiable. But one more function, one more condition is given in the Rolle's theorem, that is f of a is equal to f of b, that you have to check. आगे के सम में हमने नहीं किया था, बट दैट ऑल्सो यू हैव टू डू. वो बोथ द सम में एफ ऑफ ए इक्वल टू एफ ऑफ बी होता ही होगा. कैसे चेक करेंगे? सो एफ ऑफ ए इज 1 एंड बी इज 2. सो एफ ऑफ 1 इज इक्वल टू, हियर इट इज 1 minus 1 0, and f of 2 square 4 minus 1, that is 3. So we can say that f of 1 is not equal to f of 2. Sorry. And therefore the Rolle's theorem is not applicable. आगे जो हमने दो एग्जांपल लिए उसमें f of a equal to f of b है. I'm sorry to forget it, but you have to write it. आपको ये कंडीशन सेटिस्फाइड हो रही है कि नहीं वो एवरी टाइम चेक करनी है, right? And therefore we can say that f of 1 is not equal to f of 2. Therefore Rolle's theorem is not applicable in all these cases. Rolle's theorem is not applicable because these conditions are not satisfied. And we say that converse is not true at all. Why? मैंने आपको पहले ही बताया, हमें चेक नहीं करना है. But if f dash c is equal to 0, that c हमें ऐसा मिल रहा है, तो उसमें से हम ऐसा नहीं कह सकते कि whether it is differentiable in this interval and continuous in this interval. So it is all in three cases you will write that the converse is not true, right? Okay. Then we will do some extra sums for the Rolle's theorem. First you do it. So here we verify the Rolle's theorem. We write here verify Rolle's theorem for this function in the given interval 1, 3. So what is our first sentence? हमें first sentence क्या लिखना है? Here it is fx is continuous at close interval 1, 3 and differentiable in open interval 1, 3, that you have to write. आपको ये लिखना ही है. It is a polynomial function, so it is continuous and differentiable. Now what you will write? F dash x. तो x cube की डेरिवेटिव 3x square. Here it is 12x plus 11. Now this is f dash x, so we'll write f dash c. So that f dash c is 3c square 12c plus 11. Now here you have to find c, which is belongs to this open interval 1, 3, such that this f dash c is equal to 0. So we will take f dash c equal to 0 ले. Then 3c square 12c plus 11 0. Now 11 3s are 33. 33 के ऐसे फैक्टर्स जिसका एडिशन 12 हो, बट 11 3s are 33 के ऐसे कोई फैक्टर्स होंगे नहीं. So how to find this c? ताकि हम फाइंड करेंगे डिस्क्रिमिनेंट d. So discriminant is b square minus 4ac. So 144 minus 4, 3 and 11. So 144, 4, that is 132, right? Yes, it is 132, and therefore d is equal to 12, which is greater than 0. So two real root is possible. Which is the real root? One is, that is, we can say that c is equal to plus or minus. Here you know that a, b and c. Yes, so we can say that minus b plus or minus root d upon 2a. So minus minus plus 12 plus or minus root 12 upon 2a, that is 6. You know how to write this, okay? ये हमें मालूम है कि हमें कैसे लिखना है, okay? So that here if you write, separate कर दो इसे. तो 6 2s are 12 plus or minus, ये 4 3s है, तो 2 root 3 by 6. 2 plus or minus 2 3s are 1 root 3. 2 root 3 by 6, so you can write 1 by root 3 because 2 3s are and root 3 cut, so it is 1 by root 3. That is the value of c. Now you will check by the calculator that कि ये जो वैल्यू है 1 और 3 के बीच में आ रही है या नहीं। चेक इट बाय कैलकुलेटर, आप पॉइंट में आंसर फाइंड करेंगे तो ये वैल्यू जो है 2 + or -1/√3 बिलोंग्स टू 113 आ रही है कि नहीं, दैट यू विल चेक बाय द कैलकुलेटर। सो वो आ रही है मतलब बोथ द वैल्यूज ऑफ दिस इज पॉसिबल, राइट। सो ये वैल्यू सी की मिलेगी। कभी कभी ऐसा होता है कि हम इसे फैक्टराइज नहीं कर सकते तो बाय दिस वे, फैक्टराइजेशन होता है तो बाय दैट वे, और एनी वे you have to find the value of c by taking f dash c is equal to 0, right? Then do this, then we'll do some more sums. Here another sum I will give you, that fx is equal to x square minus 4x plus 3 in the interval 1. Okay, the interval remains same. So fx is continuous and differentiable in closed interval and open interval. That line is same, right? Continuous in closed interval, differentiable in open interval. Then we will find f dash x. Now f dash x, that is the derivative of x square minus 4. We will take f dash c is 2c minus 4. So how to find c? By taking f dash c is equal to 0. So we will take 2c minus 4 0, then c is equal to 2. जब simple linear equation आ जाता है then it is easy to find the value of c, right? So it is c is equal to 2. Whether it belongs to 1 and 3? Yes. So we will write c is equal to 2 belongs to open interval 1 3 such that f dash c equal to 0. You understand that? So this is the next sum, extra sum हम कर रहे हैं, that you keep in mind. Okay? Then next, third, fx is equal to x in the bracket x minus 3 whole square in interval 0 to 3. So this is again the polynomial function, we know that, right? So आप क्या करेंगे, it is continuous in 0 to 3 close interval and differentiable in 0 to 3 open interval. Understand or not? Yes. Or also one more thing we left here, हम एक चीज भूल रहे हैं। आगे का सम जो था उसमें क्या था, here it is x square minus 4x plus 3. So at 1 3 था, I'm sorry, but मैंने आपको बोला कि ये आपको चेक करना है। So f of 1 minus 4 plus 3 plus 1 4 minus 4 0. f of 3 9 minus 4 3s are 12 plus 3 12 minus 12 0. So you will write f of 1 is equal to f of 3. ये आप every sum में करेंगे, I'm sorry I'm forgetting it, आप every sum में करेंगे, right? Okay, now for the next sum is here fx is equal to x in the bracket x minus 3, right? Okay, so first of all it is continuous in closed interval and differentiable in the open interval. Now you will find f of 0, तो हो जाएगा 0. f of 3 again 0. So we'll write f of 0 is equal to f of 3 and therefore now we'll find fx. पहले तो fx को सिंप्लीफाई करना पड़ेगा, होल स्क्वायर है, डोंट डू द डायरेक्ट डेरिवेटिव. सो हियर x square minus 6x plus 9, x cube minus 6x square plus 9x, right? Okay, now f dash x 3x square 12x plus 9. So can we take 3 common, right? अगर नहीं रखना है तो भी चलेगा, दैट इज 3x स्क्वायर एफ डैश एक्स है. ओके, नाउ we'll take f dash c, so that 3c square 12c plus 9. We will take f dash c equal to 0. 3c square 12c plus 9 0. We'll take 3 common. So 3 common हो जाएगा, c square 4c plus 3 equal to 0. Now we can factorize it directly. That is c minus 3. c minus 1 is equal to 0. Now what is it? c is equal to 3 or c is equal to 1. Here if you get the 2 values, then you have to select that which value is possible in the open interval 0 to 3. हमारी condition है c belongs to open interval 0 to 3. So c is equal to 3 does not belongs to open interval, right? So we will write c is equal to 3 does not belongs to open interval 0 to 3. Therefore, c is equal to 1 belongs to 0 to 3 such that f dash equal to 0. हमारी acceptable value कौन सी होगी? c is equal to 1. Understand that? Yes. Do it. Then we'll go ahead with the next sum. Here fx is equal to x cube minus 6x square plus 11x minus 6 and x belongs to 3. The condition is given. So now this is again the polynomial function. So we will write that fx is continuous in closed interval 2 3 and differentiable in open interval 2 3, right? Now we'll check f of 2 cube, that is 8, 2 4 24, 11 2s are 22 minus 6. Now here 8 minus 6 is 2, 22 plus 2, 24 minus 24 becomes 0. Then f of 3, 27, 54, 33 minus 6, right? Check out whether it is equal to 0 or not. Minus 6, that is 54. Yes, it is 0. So we will find that f of 2 is equal to f of 3. So now find f dash x. What is it? 3x square, 12x. Oh, this is repeating. I'm sorry, this is again repeat. So don't do it. हमने already कर दिया है. So directly write the value of c. It is repeated, right? So don't do that. Now we'll go on the next sum. Okay. Now here fx is equal to under root of 9 minus x square. X belongs to minus 3 3. Right? Here again under root भले ही है, फिर भी वो है तो polynomial sum. And therefore we'll write that fx is continuous in closed interval and differentiable in open interval, right? Okay, and therefore f of 3 find करो, sorry पहले minus 3 find करो. What is it? minus 3 का square भी 3 ही होगा, 9 ही होगा, that is 0. And f of 3 is also 0. So it is obvious that f of minus 3 is equal to f of 3. ये obvious है, right? Okay. Now we'll find f dash x. तो जब डेरिवेटिव फाइंड करेंगे, फर्स्ट ऑफ ऑल डेरिवेटिव ऑफ द स्क्वायर रूट फाइंड करना पड़ेगा. सो इट इज 1/2 रूट 9 माइनस एक्स स्क्वायर इंटू नीचे ब्रैकेट की डेरिवेटिव, ये बेस की डेरिवेटिव होगी माइनस 2x, सो दैट इट इज कैंसल. So we can write f dash c is equal to minus c upon under root of 9 minus c square. Yes or no? If you write c, okay. Now we'll take f dash c is equal to 0. minus c upon under root 9 minus c square 0. What do you say about that? हम इस पर से क्या लिख सकते हैं? ये इधर जाएगा तो 0 हो जाएगा. That means we can say that c is equal to 0 and 0 belongs to this open interval. Yes, so c is equal to 0 belongs to open interval minus 3 3 such that f dash c is 0. By this way you can find the value of c. You understand that? Okay, do it, then we'll go ahead for the more sums. Okay, fx is equal to sin x. In 0 to pi you have to verify the Rolle's theorem. So first of all we know that all the polynomial function as well as the trigonometric function is continuous in closed interval and differentiable in open interval. वो मैंने आपको पहले ही बता दिया है. So that we can say that fx is continuous in closed interval 0 to pi and differentiable in open interval 0 to pi. Therefore, here is the f of, first of all we'll find f of 0 and f of pi, it should be equal. F of 0, sin 0 is 0. F pi, sin pi is again 0. So f of 0 is equal to f of pi. So now we can apply the Rolle's theorem. If find f dash x, so that the derivative of sin x, that is cos x. Now f dash x is equal to cos x, then f dash c is equal to cos c. Now what? Here is the cos c is equal to 0 लेके you have to find the value of c. How to find it? Take f dash c 0. So you will take cos c is equal to 0. Now zeros of cos, that is 2n plus 1 pi by 2, n belongs to z. पर हमें कौन सा लेना है? Between 0 to pi, and therefore it is c is equal to 0 to pi में cos कहाँ पे 0 होता है? Pi by 2 पे. So it is c is equal to pi by 2 will take, which is belongs to open interval 0 to pi, such that f dash c is equal to 0. You understand that? So here, that way for the differentiation rule and continuity and differentiability of the trigonometric function, we can verify the Rolle's theorem for the trigonometric function also. Same way, if it is the function is given, fx is equal to, instead of that it is sin x plus cos x minus 1, x belongs to 0 to pi by 2, right? If it is given that. So we know that this is also the trigonometric function, and trigonometric function is continuous in closed interval 0 to pi by 2, open interval 0 to pi by 2 में differentiable हो जाएगा. So now f of 0 and f of pi by 2 will find. Here first we will find f of 0. What is it? Sin 0 cos 0 minus 1. Okay. Sin 0, 0. Cos 0, 1. Minus 1, 0. F of pi by 2. Here it is sin pi by 2, cos pi by 2, minus 1. Sin pi by 2, 1. Cos pi by 2, 0 minus 1. It is again 0. Therefore, we can say that f of 0 is equal to f of pi by 2. Right? Okay. Now, we'll find f dash x. What is the derivative? Sin, that is derivative cos. Cos, the derivative is minus sin x. And the derivative of 1 is 0. We'll take f dash c. Here it is cos c minus sin c. Now it is what? Take f dash c 0. So we take cos c minus sin c equal to 0. If cos c minus sin c equal to 0, then we can say that cos c is equal to sin c. Now you know that when the value of cos and sin is equal, at which point it is equal. We know that cos pi by 4 and sine pi by 4 is equal. Yes, and therefore here it is. We can say that C is equal to pi by 4. We'll check it out whether it is in 0 to pi by 2 open interval or not. Yes, it is between the 0 to pi by 2 open interval such that f dash C is equal to 0. So anyhow you have to find the value of C, but it should be in the open interval which is given AB, right? So this is the sum. Okay, then we go ahead do it. So now I will write here the next sum. F of x is equal to e raised to x sin x minus cos x in the interval pi by 4 and 5 pi by 4. This interval is given. Now fx. First of all, it is trigonometric function, and trigonometric function is continuous. We know that. So we write fx is continuous in given closed interval and differentiable in open interval. This is the first line which is continuous and differentiable that you have to write. It is compulsory. Okay. Now, first of all, we'll check whether f of a is equal to f of b or not. So, f of pi by 4 e raised to pi by 4 sin pi by 4 minus cos pi by 4. But we know that the value of sin pi by 4 and cos pi by 4 is equal. So it becomes 0. We know that. Now f of 5 pi by 4 sin 5 pi by 4 minus cos 5 pi by 4. Again sin pi plus and pi plus. Both is negative in third quadrant. Both the value is same. That is, again it becomes 0. Right? Okay. So that f of pi by 4 is equal to f of 5 pi by 4. We say that f of a is equal to f of b. That's why here, now we can apply the Rolle's theorem. F dash x is, here is the 2 function is there. So you have to use the multiplication rule. What is it? E raised to x constant. Derivative of this bracket is cos x plus sin x. You know why? Derivative of cos is minus sin. It is constant. And derivative of e raised to x is e raised to x. Therefore, e raised to x cos x, e raised to x sin x plus e raised to x sin x minus e raised to x cos x. Expand the brackets. Then what is it? Cancel. So our derivative 2e raised to x sin x, that is f dash x. You want to find the value of c. So now we will take f dash c is equal to 0. So that here f dash c is what? 2e raised to c sin c. So here we can take 2e raised to c sin c equal to 0. But you know that exponential function is never 0. E raised to c की value 0 कभी नहीं होगी. That means what is 0 here? Sin c. And therefore we can say that sin c is equal to 0. What is the zeros of sine? That is and pi n belongs to z. Pi, 2 pi, 3 pi, 4 pi and all are 0. But our interval is pi by 4 to 5 pi by 4. Or pi by 4 to 5 pi by 4 में क्या आ जाएगा? It is pi. Right? Okay. So that we can say that c is equal to pi. हमें interval देखना है. Here is pi by 4 to 5 pi by 4. Here is 3 pi by 4. So between this interval, pi, 2 pi, 3 pi, 4 pi, what is that? Here it is pi, right? And therefore C is equal to pi belongs to this open interval pi by 4 to 5 pi by 4 such that f dash C is equal to 0. It becomes 0. So the answer is C is equal to pi is our final answer. Understand that? Okay. Then the next sum is fx is equal to a raised to sin x in the interval x belongs to 0 to pi, and the condition is given a greater than 1. That means a is not negative, and if it is 0 तो भी वो गलत हो जाएगा. So it is given condition is a greater than 1. Okay. So first of all, it is trigonometric function a raised to sin x. So we can say that what is it? Fx is continuous in closed interval and differentiable in open interval 0 to pi. Understand that? Okay. Then find out f of 0. So a raised to sin 0. Sin 0 is 0. So a raised to 0. That is 1. F of pi. A raised to sin pi. Sin pi is again 0. So a raised to 0 is 1. So now we can say that f of 0 is equal to f of pi. Right? We get the same value. And therefore, here if we apply the Rolle's theorem, so we'll find f dash x. What is this? Derivative of a raised to the power any function. So, a raised to x की derivative क्या होगी? A raised to x log a base c. So, here a raised to sin x log a base c into d by dx of this sin x is cos x. So this is our f dash x, right? And you have to find that f dash c. Wherever it is x, you replace by c. It is a raised to sin c log a base c base e cos c. Okay. Now what? Log a base c is not 0. This is the function which is exponent, so it is also not 0. तो फिर 0 क्या होगा? ये, right? So what we apply here? F dash c 0, a raised to sin c log a cos c equal to 0. Log a is not 0. This is not 0. Exponent में कभी भी 0 नहीं होता. So what is 0? Cos c is 0. So now we can say that cos c is equal to 0. अगर cos c 0 है तो बोलो 0 की 2 पाई में कौन सा 0 आएगा cos का? Pi by 2. वो आगे आ चुका है. So here we can say that c is equal to pi by 2 belongs to open interval 0 to pi such that f dash c is equal to 0. You know how to select this? Right? The open interval 0 to pi में cos कहाँ पे 0 होता है वो आपको देखना है. So it is pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 and all zeros of the cos. पर हमारे interval में कौन आएगा? Pi by 2. That will write pi by 2. You understand that? Okay. Then a raised to sin x. Then here is another function is given. Fx is equal to e raised to x into cos x. The function is given e raised to x cos x. Again it is continuous, but the interval is given x belongs to minus pi by 2 to pi by 2. Okay. Now what? It is continuous in the closed interval. ये तो आपको लिखना ही है. Differentiable in the open interval. Okay. Now we will find f of a and f of b is there or not. F of minus pi by 2 If you write f of minus pi by 2, that is e raised to minus pi by 2 cos of minus pi by 2. You know cos pi by 2 is 0. That means what? ये 0 हो जाएगा. So here it is equal to 0. Now f of pi by 2 cos pi by 2 again 0. So we can say that f of minus pi by 2 is equal to f of pi by 2. So this is same. So we can apply the Rolle's theorem. So first of all we'll find the derivative f dash x. Here you have to use the product rule to find the derivative. So e raised to x constant, derivative of cos is minus sin x, plus cos x constant, and derivative of e raised to x is e raised to x. That is the product rule. Okay, that means we can say that e raised to x cos x minus sin x. This is our derivative. E raised to x common ले लिया, right? Now we'll take f dash c, e raised to c cos c minus sin c. Now take it, f dash equal to 0. That is what? E raised to c cos c minus sin c 0. But again the exponent never 0. So we can say that e raised to c is not 0. So what is 0 then? Cos c minus sin c. So here we'll write that therefore cos c minus sin c equal to 0. So we can say cos c equal to sin c. Now you tell me cos c equal to sin c कब होता है? Whenever it is equal values. When c is equal to pi by 4. Cos and sin की वैल्यू इक्वल कब है? जब c is equal to pi by 4 है. Therefore we can say that c is equal to pi by 4. Now check whether it is in our given interval or not. So minus pi by 2 to pi by 2, that is the fourth and first quadrant. उसमें pi by 4 आ जाता है, right? So we can say that c is equal to pi by 4 belongs to minus pi by 2 to pi by 2, such that f dash c is equal to 0. Right or wrong? Yes. So by this way, if the polynomial function is given or the trigonometric function is given, we can find the value of c for any given function such that f dash c is equal to 0. But the necessary and sufficient condition is what? The function should be continuous in the closed interval and differentiable in the open interval. Again, another condition is f of a is equal to f of b होना चाहिए. Then only you can apply the Rolle's theorem. If it is not equal, then we cannot find the Rolle's theorem. You understand that? Okay. So now, one or two more sums that I will give you that you have to do it yourself. Right? That is your homework, you may say. Here is first, fx is equal to x cube minus 4x plus 5, where x belongs to, 0 to 2. Right? That you have to find the Rolle's theorem and find the value of c. Okay? Then another is fx equal to x square minus 4x plus 3. X belongs to 1, 3. Okay? That again you have to find the value of c. First, y is equal to x square plus 2. Okay, that is done. X square only. X belongs to 2 to 4. If it is possible, then verify the Rolle's theorem. आपको possible है तो verify करना है, that you keep in mind. Then fourth, fx is equal to x minus 2 sin x, where x belongs to minus pi to pi. Okay? Here is the sums that you have to do it yourself. This has some sums that you apply. If it is possible, मतलब continuous and differentiable तो होगा ही, but f of a is equal to f of b है, then only you apply the Rolle's theorem. Otherwise, Rolle's theorem is not applicable. If it is applicable, then find the value of c. Okay? Then with next period, we will see the mean value theorem for the continuity and differentiability. That is another theorem that we have to see, and that is the last theorem. So we here now to the end of the chapter in the next period. Till then, goodbye. You have to do this sums of yourself. Make a practice of Rolle's theorem. It is very easy. Okay? We'll meet in the next lecture.